All right, good morning. I'll plan on doing biweekly contest 73 from last Saturday. So I'll do this virtually. Here we go. Alrighty, open these guys up. Unless we can number following array and Hakeem array. Okay, the target's 100. There are two occurrences at those values. No under integers follow the occurrence key. So return 100. Count the number of times target immediately follows the occurrence of key. Nums of I plus 1 equals target for every unique integer target. Return the target with. Oh, okay. So what is the maximum account after that key? So we should just be able to use a map, right? Okay, so here's my game plan. Use an unordered map to track counts then of values following k, the value k. Then return max frequency. What if there's a tie? EH2, so there's target 2 follows a 2. Oh, the key can follow itself. Interesting. Any value after itself. Okay. Let me check the time, 4:50 a.m. We'll start the implementation. Oops, current. For each X and A, keep track of last. Oops. Last equals X, and then we'll do a map. Map will be our unordered map, which will be our counts. Counts of value preceding K. If last is equal to K, plus m sub X. And then we'll keep track of a high. High and a high count. Auto high count. Or maybe best target. Make pair. Best will be 0. Target will be -1. Return the target in the end. If best is less than that, then target equals X. Last equals K. Okay. I still don't know what will happen if there's a tie, though, isn't it? The test. Oh, okay. There is a maximum count. It's unique. Okay. So there is no use case of a tie. All right. This one should return 2. Looks good. Oh, it's returning 3. Last equals K. Best is less than m sub X plus plus. If last equals K. Last is 2, which is K. 1, 2, 3. 2 should occur 3 times. So x target best. Okay, something's not right here with the logic. Let's see if we can print out the map. Key value in the map, I can just print it out. M sub e equals value. Yes, M sub 2 is 3, so why is it not for each x and a? If last is k, and last is t. How about t is target value that I'm looking for? And it's target x. Oops. Last is x. Best is less than. Oh. Best equals m sub x. Target and best. Auto may answer. And then the best. Tuple. -1 and 0. And -1 is just a sentinel value. Okay, so this will be the answer. Okay, so that should do it, right? We need to just reset the best to that current count. There we go. Okay. That looks good. Ka-chow. Okay, 450, 455. About 5 minutes. And this is a pretty decent solution. We can do this, else equals x, and we can get rid of these squiggly things. If, oh, wait, no. I'll just leave that. It's okay. If this and that, then this. It's a little bit more concise. Looks good. Okay. Let's do this in the other languages here real quick. Keep track of the best and the last solutions, and do this in Rust. Python 3. TypeScript. Do it in JavaScript. Oops, JavaScript. I can type. JavaScript. Okay, and we'll do this in Kotlin too. Okay, let's jam on this real quick and then get on to the other questions. I'd really like to get to Q4 with a sufficient amount of time to actually do it. So let's do this real quick. Okay, so then last equals -1, and then the answer best count will be these guys. Return the answer. Oop. Okay, and for x a, last x, if last target, and best is less than m sub x. M is our map. Let's do this actually. Let's do a default dict. So it'll place the integer value 0 there by default. Answer equals x, and then best equals m sub x. Hold on. I want to do this. M sub x plus equals 1, and if this, then that. Last and best. Okay, that looks good. Ready. Python 3. I'll come back and do rest. That's my most challenging language for sure. Let's do this real quick here. There's our array, our target value. All right, let's do last -1, let answer and best equals, all right, return the answer for each x, input array A, last x, if last is the target. And, oops, hold on, we have to set our map here for our counts. X1 plus m.get x or 0 if m.get x best is less than that, then that's m.get x and the answer is x. That looks good. Okay. JavaScript. Using Kotlin. Array, target. Last, let's see, answer last best equals triple -1, -1, 0, return the answer for x and a. Last equals x if last equal to our target, and then do m x or m equals full map of, this will be our counts, of x equals m sub x 1 plus x Elvis operator that doesn't exist. All right, if best is less than m sub x, then answer is equal to x and best equals the count of x. Okay, looks good. Uh-oh. Best, there we go. Looks good. Yay. Okay, grab that, stick that there. Okay, we'll do TypeScript and Rust and then move on. Let's go. TypeScript. T. Answer last best equals some sentinel values and the count initialized at 0 for x of a. Last x, if last equals the target value, and will be our map. Set 1 plus m.get x 0, m.get x less exceeds best. Get x, and the answer is x. Okay. Looks good. Pretty much the same thing as JavaScript with types. And I'm not sure if I'm using that right or not. Okay, let's do Rust and then let's hit this thing. Okay, there's our array and our target value. Vector by 32. Okay, let's mutable answer, mutable last, mutable best equals -1, sentinel values and 0. Return our answer in the end for x and a. X if last t. Let mute m equals hash map. New m sub x increment the count if, oops, pass is less than m sub x. Object and location m.get x.or entry 0. I think, hold on. Get m.entry x.or insert 0. Let's go 1. m.entry sub x. Best equals m.entry sub x. Object location of that. Okay, and then the answer is x. Right? Okay, let's see what happens here. Compile error not found in the scope. Okay. Use std collections hash map. M.entry cannot be dereferenced. Or insert 0. Or here, let's do this. Let mute entry equals this guy. Entry plus equals 1, right? And then I'm going to use it still. What? Come on. Entry. There we go. All right. Yay. Okay, that wasn't too shabby. Boom. All right, grab these guys, stick them on my post, and move on to the next question. A few solutions. Bam. All right. Use a map m to count each value x of the input array A, where x follows the last value equal to target t. There we go. Looks good. Okay, let's move on to the next question. Okay, so where am I at? I took about 18 minutes for Q1. Okay, so 1 hour, 12 minutes for Q2. 1 hour, 12 minutes left. So Q1, that took about 18 minutes. Okay, this guy, we'll pump this guy out here real quick. Yeah, mapping and numbers. Okay, let's go read the problem statement. You're given a zero index integer array mapping. Represents the mapping rule of shuffled decimal system. Okay, this digit maps to that digit. Map value of an integer obtained by replacing the digit I and the integer mapping by. Okay, that makes sense. Mapping 9 equals 6. So all occurrences of the digit 9 will become 6. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, that makes sense. Okay, so basically we're just replacing each digit in our array of that. I'll just call it map is okay. Just M. Yeah, that looks good. Okay, so basically perform a linear scan of the input array A, transforming each digit per the map M. That's my game plan, right? Game plan. Okay, and then we're going to start at 5:08 a.m. All right, let's jam on the implementation here for auto X A. Okay, so each digit, I wonder if it's easier to change it to a string and then change it back into a decimal. That's what I'm thinking. We'll have some kind of function which will input X and then it'll input it into a string stream. Take an X and then string S, output it to a string. And then for each character, what we can do is transform it and then return the string to an integer in the end. Oops, excuse me, for auto each character by reference so we can modify the string in place. C equals M sub C, basically. Right. The map of the character, the integer value of the character, integer value of the character, C minus 0 to offset it. Dokie. Let's see, transform. Again. Oops. S dot end, S dot begin, right? Put it in place. Okay, and then we'll pass in the map by reference. Return M sub C minus 0. Stick this in one line. Okay, that looks good. So that's our function that'll transform each value X and A. So then what we'll do is transform. Just do a linear scan of the array and put it in place. And we'll capture the function and everything by reference. Turn the transformed array. Return F sub X. Okay, that looks good. See what happens. And I need to grab it by reference here. STOI, invalid argument. What? Return M sub. What? A string representation of that. What? Hold on, let's just output it. Input is X. Output is S. Let's see. 9 and 1. Oh, wait. I'm not outputting. Oh, okay. For auto X and A, F sub X. All right, just invoke it. Let's see what happens. Input is 991. Output is nothing. What? Take in X. Oops, I have this backwards. Take in X and output it to S. Oops. Okay. Well, that didn't work either. What the heck? Why is this string empty? What the heck? F sub X. Input's 991. Not return anything. How is the output? String stream. Input X. and an output to S. What? How is this not working? Input X. X is an integer and output it as a string. What the heck? String stream, input integer, output string. The heck? Come on. Really? String stream. I want to input. What a junk post. Come on. String stream. Come on, I know how to use this thing. What the heck is this? Input an output to string. X output. What the heck? String representation of that thing? Come on. String. Let's see. Let's do a output string. Or maybe I did have that right then. What the heck? OS. Okay, well, this works, right? Yeah, let's do this. It's been a while since I've done input output, I guess. How is this string somehow modifying it not right? Transform all those things, and then each character of the string is modified to be that character. This. Ooh. Bunch of question marks. Transform each character. Imps character plus 0, not minus 0. 669, does that look right? No. The 9 should be transformed to a 3, 0, 1. What? It's, oh, sorted array. Oh, okay. Output a same relative order. So 3, 3, 8 becomes 4, 3, 8. Zero, 1, 2, 3, 4, 5, 6. So all occurrences at the digit 9 will become 6. The map value is 669, 007, or 7 after leading to zeros. Plus the sorted array. Is that correct? Doesn't look right. Oh, okay. So we don't modify it, but we do sort it based on that. So we sort it based on that key. Okay. Sort A based upon mapping key. Leading zeros are omitted. Okay. Using order, let's do this, just map unordered. So this is associate the transformed value as the key, the sort key. Okay, associate the value and the transformed value, right? X and transform value mapped X sort key. Okay, so let's do this. N equals data size, VI. I guess, yeah, we don't need a map. We can, Do I need to keep track of the index as well, or just, how am I going to sort these things? Sort by key. I think there's a custom comparator we can pass into the sort function. Okay. 007. There's a tie. Same. Okay, so I need a stable sort then, right? So C++ stable sort with a custom comparator, right? Okie dokie. Stable sort. Pass this thing in by reference. Auto, oops. A, auto B. Return F sub A less than F sub B. So that'll be the comparison. Okie dokie, and then return A. Do not transform A though. That does not look right. Is it 3383? Oh, it is. Okay, yeah, that is right. Okay. Use that example test case, and it should be that order. Okay, looks good. It's taking a while. Uh-oh. TLE. Holy cow, this sucks. Mapping length. Okay, these, all the values of mapping. Okay, these are unique. If there's 30,000. You know, this is not fair. C++ has a hard time with TLE sometimes. It isn't fair. C++ is given an extra hard time. So, okay, instead of mapping them all to strings, Okay, we can use a cache to see if we have these looked up values already. Assuming these things are going to occur more than once. Look up the key. There's a cache. Cache for calculating keys. Map cache. If cache.find x equals cache.end, then do this. Stick it in the cache. Cache sub x equals that. Turn cache x. Looks good. See if it'll run this big O input faster. Looks maybe a little bit faster. Oh, okay. Yeah, that worked. Okay. Okay, cool. So using a cache for the function which calculates the key results in AC. All right, so we don't have to calculate more than once, basically. And then a stable sort. Okay, this is like a pretty good solution. Okay, 5082525. That took about 17 minutes in C++. Okay, and then we'll do this in the other languages here real quick. If they have a stable sort, that would be really nice. Otherwise, this is going to be a huge pain. I wonder if Lodash has a stable sort. Hold on. Sort. Not what I want. This method does perform a stable sort by. Okay, cool. Let's do that then. Python 3, Rust. TypeScript. JavaScript, and for JavaScript, we use the Lodash sort version for stable sort, and I'm pretty sure Kotlin has stable sort, so it's cool. And Python, I suspect it has a stable sort. I don't know. Let's just do JavaScript next, and back to the other ones. So we can use the Lodash sort by stable sort. Okay, so here's our map, our array. F will be our function, which takes in X and maps it to another value, underscore sort by a F. Return sorted array. I guess we can put this in line. Okay, and then do our string representation of X, and then for let string, and then T will be our transform string, which will transform into an integer after we join it. Return number t.join. Let each character of the string split. Okay, and then t dot push, look up the character in M, and then transform it to integer, so it'd be number sub c. Character, let's change the character then, right? C equals transform it to character and stick it in there. Number. Transform that into number. Join to number. It should be already is a number in this. Okay, so just do this. Push map number. Join. Okie dokie. Let's see what happens here. Example test cases. That does not look right. I do this. Join dick. Doesn't look right. Oh, that is correct. Okay, so then number. Why is A not? Oh, does it return a copy of A? Okay, so that makes sense. All right, let's do this. Return underscore dot sort by A. Oops. Actually, let's just return this, right? Okay, it'll just be a one-liner. 3383891. That looks right. The other test case. Okay, and then I need to. Oh, okay, that works. Cool. One-liner. It's pretty awesome. Wonder if I can clean this up a little bit. Yes, I think we can. Let's do this. Tick tick. String dot split into individual characters and map each individual character based upon its numeric value in the map, and then join that back into a string as a number. Oop, hold on. Okay, there we go. Oh, missing a right paren. Oop. Yes, the sort by. Go. Looks good. Yay, that's a cool little one-liner. Boom. Who cares about TypeScript, right? Whatever, it's the same thing as JavaScript. As far as Leetcode is concerned, it's pretty much the same thing as, let's see, sort, stable sort in Python 3. Sorted, is it guaranteed to be stable? Yes, sorted, just that thing. They are stable. Okay, cool. Nice to know that Python sort is stable. Okay, let's get this done in these other languages, and then let's get on to Q3 and Q4. I don't want to waste too much time here. 5:33 a.m. for Python implementation. Okay, so we're going to want to sort it based on the mapping of f(x), and then return sorted a key equals comp to key lambda x f sub x. f sub x, so basically transform it into a string. All right, string representation of x. For each character in the string, we'll create t, which we can join together, t dot append m sub n sub c int c for cn s no, let's just do this. T dot append this thing and then return T dot join that guy. Okay. Oop. 2 were given. Let's see. Python 3 sorted function. Sorted. Iterable key equals. That's what I thought. It's going to old style compared to key. Didn't I type that? Key equals come to key. Oops. Come to key. S of x. What? Takes 1 positional argument, but 2 are given. I want it inline, right? Sorted a. I don't. What the heck? F x sorted. What? Pretty sure I have an example of this somewhere. Let me go look it up real quick. Come on, let's get to it. It's taking too long. Okay. Comp to, yeah, the last time I looked this up is already here. A dot sort, come to key. Oh, okay, I see. Come to key, so we need A and B. F sub A minus F sub B. Okay. No, what? Int, oh, expected string, T dot append, tick. Turn that into a string, turn it together. Looks good. Maybe it'll TLE. Okay, let's see. Cache equals that guy. If X not in cache, stick it in the cache. Cache X equals that guy. Turn cache X. Okay, it's quite a bit faster. Still kind of slow. Okay, cool. I thought I was gonna TLE. Okay, 5:38 a.m. About 5 minutes. It's cool. Not too shabby. Okay, there's Python 3. All right, let's do rest in Kotlin, move on to Q3. Hopefully I have enough time for Q4. Let's get to it. All right, so font F, integer, return an integer. Okay, let's do this. Kotlin stable sort. Sort, is it default stable? Oh, it does do it in place. So sort. What is it? It is stable. Okay, cool. That's always nice if it's stable sort by default. Return sorted A, Kotlin. Oops, Kotlin sorted. Phew, bless me. It is a stable sort, and then I want to pass in sorted by comparator. Let's see, Kotlin sorted with comparator. Was it sorted with or yeah, okay. Sorted with. That's what I want. Sorted with, okay. Sorted with comparator. A is an integer, B is an integer, and return F sub A is less than F sub B. Started with, okay, so S equals string representation of X. T will be our mutable list of integers. Turn T dot join to string, empty string, dot to integer. For each character in the string S, T dot add the character mapping M sub C to int minus 0 to int. Add that value onto T and then join it. Okay, let's see what happens here. Expecting, oh, should be a pair. Pair to destructure. Okay, does not like the sorted with. Int is expected. Sorted with mismatch. Oh, should be subtraction. Unresolved reference. Receiver type mismatch. Comparator. What? To int. Now let's do this. Oops. Turn the array, but then let's just print this out. For X in A, println F, oops, S of X equals S of X. Let's use our example test cases. Oops, println. Come on. 669, that looks right. Okay, so this part's okay, but the sorted with part is not okay. Come on, what is this? Custom comparator. Let me see if I have an example in Kotlin here real quick too. I haven't done a custom comparator in Kotlin in a while. Do this sorted with, oops. Sorted with comparator if, oh. Okay, yeah, so that's the A minus F sub B. Looks right. Unresolved reference. None of the candidates is applicable because of receiver mismatch. What? Integer. Character. Sorted with. The heck? What's wrong with this? F sub. Comparator. Is it something like this that needs to be done? To int? No. Receiver type mismatch. What the heck? It's integers. Isn't it? Integer x, output integer. This minus that. Sub x. It's not compiling. Oh, is it sorted? Hold on. Sorted with Kotlin, sorted with. I'm getting sorted with, sorted by. A dot sorted with. Aha. Okay. Thought that would work. For the, oh, it's in to int array. Okay, that was good. And we might need to add the cache if it TLEs. I think we will. Our cache equals mutable map of int to int. If the cache does not contain x, then we'll stick it in there. Calculate it once and stick it in there. M sub x equals that. Oops, cache x equals that. And then return cache x. Okay, here we go. Here we go. Okay, Kotlin's cool. Kotlin, JavaScript, Python 3, and Rust. I don't know if I want to do a custom comparator or not. This might take a while. I'll have to figure this out. Let's see, stable, sort, and then custom comparator. Sort is stable and vector. Okay, that's cool. So Rust, sort with custom comparator. Sort vector with comparator. Sort by. Error.fold, accumulate. Sort by, items that sort by, okay. Let's try this, let's see what happens. And if it takes too long, I'm going to just move on because I'd like to get to Q3 and Q4. How much time do I have left? Oh, geez, 29 minutes left. Holy cow, I used a whole bunch of time. Let's see, 17 minutes, 5. Okay, so 5:25 a.m. to 5:49 a.m. It took me 24 minutes for Python 3 plus Kotlin plus JavaScript. Just trying to figure out where all my time's going here. It does take a little bit of time to look up some of these things because I haven't done a stable sort in a while, but man, I am slow. Okay. All right, whatever. Slow and steady, I guess, wins the race. I'll get there eventually. I hope. All right, whatever. Type BI equals back to. All right. BI. And turn a dot sort by f sub a minus sb. Fn f integer I32. Turn an I32. String. You change an integer to a string. Rest integer to string. Is there a two-string function? Two-string. Yeah, there's a two-string function. That's T. Okay. Turn. Rest. Join. Vector. Characters. Into iter.collect. Iter.collect. See, string to integer. Rest string to integer. Nice. That parse to unwrap. The parse colon I32. Unwrap. Parse I32 dot unwrap. Okie dokie, and then for each character in the string, look it up in the map. We need to pass in the map here. For each characters in the string, T is mutable. T dot push the integer value. Integer value of the character. Rest character to integer. Chars two-string parse I32. Okay. Two-string parse I32. to string parse I32, unwrap it. Push that thing, that to string, m sub, that guy. Okay, let's see what happens here. Sample test case. Okay, what's it complain about? Expected I32 and ampersand I32. Okie dokie. Location A, location B. Use the thing instead. Okay, it returns an I32. Expected enum comparator ordering found I32. Cannot infer type. Oh, I better change it to U size. U size. Expected enum found I32. Sort by what? Rest sort. Oops. Sort by. Sort vector. Sort by. Partial comp to unwrap. Need a partial map to unwrap. Partial comp. Partial comp. What is this? Asymmetry. Some ordering. Partial comparison to this thing? I expected that ordering found an option. Sorted by? It worked. There's no sorted by. Maybe that's sort by. Oh, I don't know if I can mutate this thing. I don't think so. Here, we'll come back to this. This is stupid. I don't know how to do this. To do, implement me. We'll do this later. Whatever. Let's move on. It's taking way too long. I'd like to get to Q3 or Q4. Few solutions. Okay. Let's see. Sort the input array A by the function f of x. Let's see, stable sort each x, each value X of the input array A via the function fx, right? That's pretty good. Use cache to avoid TLA when computing the use your cache to avoid TLA when calculating by remembering, right? Remembering the output, I guess, the output key of f sub x. That works, right? Stable store each value x of the input array A via the function of x. Use a cache to avoid TLA by remembering the output of and the output of f of x. There we go. Use a cache for the output of f of x. I guess to remember large inputs. Yeah, it's kind of implied. Okay, that looks pretty good. We'll come back and implement the other one. Okay, all ancestors in a node in a directed graph. Okay, how much time do we have? 17 minutes. Oh, not much. So I guess a key takeaway, right? Key takeaway is that I guess solving in multiple languages is still kind of slow for me. Whatever, I mean, it's good practice, I guess. And okay, so this looks cool. It's a graphing problem. Let me go get some more coffee and then I'll read the problem statement. Yeah, I'll be right back. time 6:04. Okie dokie, 6:04 a.m. You can positor in. Okay, that's how many nodes we got. Zeroed in -1 inclusive. Okay, there's the edges. So it's an adjacency list of edges. All right. Unidirectional. Okay, so it's directed. List of ancestors of the ith node in ascending order. A node U is an ancestor node of V. If U can reach V via a set of edges. Okay, so we're just looking for a topological sort then? So output 0, node 0 does not have any ancestor. Kiduki. I'm thinking just a def first search for topological sort, or either breadth first search or depth first search, right? To do breadth first search, we can do in degree 0, start from there. You avoid TLE though. This is a quadratic output. 2,000, 1,000. There's 2,000 edges and 1,000 vertices. Yeah, this one's going to be the hardest part of this one. I think is going to be avoiding the TLE because the quadratic output, like you build upon it. Let's see. Okay, I need to decide if I'm going to do breadth first search or depth first search. Breadth first search gives us the added advantage is the recursive stack unwinds. Right, we DFS into it as a recursive stack unwinds. You can build up 0, 1, 2, 3, 0, 1. Hold on. Zero, 1, 2, 3, 4, 5, 6. Right, we should be able to build them up this way, I think. So 6 will be 3, 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, and 4. Oh, all of these things. This guy is all of those guys. So maybe dynamic programming to build these things up, like reverse the graph, maybe? Does it make sense to reverse the graph? I wonder. Seen. Thinking maybe pre-processing by reversing the graph might be beneficial. There. Or what's been seen previously, maybe. What's been seen here is 0. What's been seen here is 0 and 3. What's been seen here is 0, 0, 3, and 1. What's been seen here is 0, 2, and 4. What's been seen at each node. What's been seen here then is what's been seen there. 5, 0, 1, 2, 3, 4, 5, 0, 1, 3. Okay. Seen a node. Okay, that's what I'm thinking. All right, here's the game plan. Game plan, BFS. Can I do that though in degree 0? Not guarantee that they're direct. Oh, it is acyclic. Okay, so that does help, right? So if it's acyclic, it does mean I can do BFS, right? BFS from nodes with n degree 0, tracking values seen per node. It's been seen. So BFS from 0, 1, and 2. What's been seen here is 0, 0, 1, 2. It's been seen. You mark yourself as seen after you go to the next node. Last has been seen. Mark last is seen. Okay, recursively. Push onto node and what's been seen. Node, what's been seen. 3, you've seen 0. 3, you've seen 1. Process. BFS next. Okay, the time. Okay, so we'll do one depth at a time, right? BFS. BFS, oops, BFS. 1K depth at a time. Value improves the scene. Building each next step of candidates. Actually, basically want to build 3 that includes 0 and 1. 0, 1, 2, 3. All right, okay. Let's do this then. A queue of pairs. Pair will be, oh, it's actually a vector of integers. All right, so as you go into each of these, you push 0 onto that, push 1 onto that, 0 onto that, 2 onto that. Integers, okay. Mark in degree 0. Oops. Using a map, goes an ordered map. This will keep track of each indices in degree. Map M. Each pair, the input array A. UV equals pair. Oops, let's do this. Tie it to that pair. Okay, then plus M sub B. 0 to 3, right? Okay, and then Q. There's a Q, and then 4. Auto. See, I from 0 to n minus 1 inclusive. Oops. To n. Minus n. If not m sub I. Q dot push works right. Push pair while Q this, process it 1K depth at a time. This is the current queue. And then the next set of candidates will be candidates or machine node, integer value should be a pair, integer value, and then we'll push all these nodes onto the next depth of the queue. Nodes, about nodes for each next adjacent node. So I do want an adjacency list too, right? Using map, their adjacency list. Adjacent view. Oops. Adjacent to u dot push back v. So from u, you can get to v. At the count of that. Nodes. Okay, so while k minus minus. So answer will be an array of size n. Okay, so pop the front into x and its previous ancestors, and sub x equals copy of that. Should just call this thing u, and we'll do each adjacent v adjacent to u. If nodes.find v nodes.end nodes of v equals no, nodes of v dot push back u. So v sub Hold on. Nodes.find v equals nodes.end. Right, v doesn't even exist, right? So and sub u equals previous. No, we don't want to do it like that. We want to push it on answer first, right? And sub I. Well, we can explicitly make it, set it there, and then set the answer here. Set answer here for each node in nodes. Okay, so if it doesn't exist, the nodes of v equal previous. And upon the previous from u, we'll append u. For auto, the predecessors of v, and so v equals pre. Okay, something like that. K minus minus for each u. Step at a time. Oh, if there's, oh, it is a tree-like structure then, right? Because it's acyclic. Maybe that does work. Okay. How much time I have left? Oh, the contest ended. Okay. Alrighty, I ran out of time, so ran out of time to do upsolve Q3 plus Q4. All right, yeah, thanks for watching. Choose. All right, I need to obviously code faster, so I have a lot of room for improvement. Catch you later.